Today we are going to be looking at section 3.1, which is all about quadratic functions. So our objectives today, we're going to recognize characteristics of parabolas, and we're going to graph parabolas. So parabolas we've been dealing with since, we've been graphing in chapter 1 parabolas, chapter 2 parabolas, but now we're going to look at more with parabolas. So remember, quadratic functions. A quadratic function is any function of the form f of x equals ax squared plus bx plus c. A, b, and c are real numbers. A cannot equal 0. Okay, that's what we call like our standard form for this quadratic function. So ax squared plus bx plus c, you cannot have a equals 0. Otherwise, the x squared term cancels, and then we have a linear function, not a quadratic function. So graphs of quadratic functions we call parabolas. Okay, so remember parabolas are U-shaped graphs. So the coefficient in front of the x squared allows us to determine if the graph opens up or down. The lowest or highest point on the parabola we call the vertex. The graphs are symmetric, and so there is a vertical line creating a mirror image. We call that the axis of symmetry. So notice that my picture on the left here, we have the parabola opening up, and that's because our a value is going to be something that's greater than 0. So anytime that a value is a positive number, our graph is going to open up. That makes our vertex the lowest point on the graph, and notice how we have this green dotted axis of symmetry, okay? When we are graphing parabolas now, I am going to want you to draw in that axis of symmetry because we're also going to be identifying that. If you look on the far right, we have a parabola that is opening down. That's because our a value is less than 0, so it's a negative value. So anytime our number that's in front with the x squared is negative, our graph's going to open down. That means that our vertex point is at the highest point. Once again, we've got that axis of symmetry. Notice that in both of these, the axis of symmetry is always going to go through the vertex. Okay, so I had said standard form is the f of x equals ax squared plus bx plus c. That's what I like to call it. They're trying to, in the book, they call standard form this equation here. I usually refer to this, though, as the vertex form. Okay, so they call it standard form in the book, but I like to call it vertex form. And that's because how we have it written here, which is how we've been dealing with graphs in chapter 2, where we can easily see like a transformation. This is because if I call it vertex form, that's because I actually can identify the vertex from this function right away. So the quadratic function f of x equals a times the quantity x minus h squared plus k, where a doesn't equal 0, like I call it vertex form. And that's because the ordered pair HK is the vertex. So notice that in the parentheses x minus h, you're going to take the opposite sign to represent the h, just like what we did when we were dealing with our transformations in chapter 2. Whatever sign was inside the parentheses with the x, we always went in the opposite direction. So that's the same thing when we're identifying the vertex. We pick the opposite sign. But then the k value, because that's outside, when we were doing our transformations, we always kept the sign the same, and that's what we're going to do here as well. We're going to keep the sign for that k the same. The axis of symmetry is going to be the equation x equals h. And hopefully that makes sense. It's x equals a number because we have a vertical line, and we want that vertical line to go through the vertex. And so it's going to always go through the x value of the vertex. So that's why h, which is in the x spot of my ordered pair, x equals h. So if a is greater than 0, the parabola opens up, like I mentioned in the last slide. When your a is less than 0, the parabola is going to open down. All right, so we're going to graph f of x equals x minus 2 quantity squared minus 1. So we're going to identify the vertex. We're going to write the equation for the axis of symmetry, and then we're going to graph and state the domains, the function's domain and range. Okay, so Like I mentioned, this is already in what I call vertex form. So I should be able to identify the vertex right away. So when it's asking for us to identify the vertex, remember the vertex is going to be HK. H is always going to be inside with the X. The K is always going to be outside of that function. I always change the sign for H. So since it says X minus 2, I really want a positive 2 for that vertex. But then because it says minus 1 outside, I want to keep the sign the same. So my vertex is at 2, negative 1. Now, because I don't see a number in front of the parentheses there, that A value is technically then a positive 1. And so because we're dealing with a positive number, I know that my graph is going to be opening up. So I know that that vertex is the lowest point on my graph. Okay, if I want to identify the axis of symmetry, which I just abbreviate as AOS, axis of symmetry, it has to be an equation. And remember, it's always going to be x equals a number, and that number is always h. So since we identified h as 2 for my vertex, x equals 2 is the axis of symmetry. Okay, so then we can honestly then understand that I can make a table of values. So in this case, because the vertex is always going to be on the axis of symmetry and it's essentially creating then a mirror image, I know that 2 is going to go in the middle of my table. So I'm going to pick 2 values to the left and 2 values to the right, and I can substitute those numbers in. So I already know that when I plug 2 in, I get negative 1 because that's my vertex. You honestly only have to pick either the top 2 numbers or the bottom 2 numbers because, like I said, it's going to create this mirror image. So if I plug in, let's just do 0 and 1. When I plug 0 into this equation, 0 minus 2 is negative 2. When I square that, I'm going to get 4, and 4 minus 1 is 3. So then that would be the same thing if I plugged 4 in, because if I have 3 at the top, I'm at 3 at the bottom of my table because I want that mirror image. Because once again, I'll just verify it. If I plugged 4 in, 4 minus 2 is 2, 2 squared is 4, 4 minus 1 is 3. So essentially, whatever number I put on the top of my table, that's going to be the number on the bottom because it's a mirror image. So then if I plugged 1 in, 1 minus 2 is negative 1. Square negative 1, you get 1. And 1 minus 1 is 0. And so that means that if I had plugged 3 in, I'd also get 0. So those are my ordered pairs. So 0, 3, 1, 0, 2, negative 1, 3, 0, and 4, 3. And so there's my parabola. I want to draw in my axis of symmetry. If x equals 2, I know that at 2, I'm going to have a nice vertical line there. So notice that whatever's on the left side of that line is also on the right because it's a mirror image. Okay, so then the only other things that I have to identify are the domain and the range. So remember, domain is the x values. So if I'm looking at all of the x values, I can substitute in any value that's negative. Notice that because I have arrows on either end, as I keep going to the left, the function is going to keep going up on either side. So my domain, there's no restriction. So I can go from negative infinity to positive infinity. My range is my y values. So while my graph is going up, I know it's going to hit all those positive y's, but notice that the lowest that my graph goes is the vertex. And so my y value for the vertex is negative 1. And negative 1 is included, so that means that I have to have a bracket. But then since it's going up towards all those positive numbers, it heads up towards positive infinity. And there is my problem. All right, let's take a look at this one. So we're going to graph f of x equals 1 minus the quantity x minus 3 squared. So once again, we're going to identify the vertex, write the equation for the axis of symmetry. We'll use the graph then to state the domain and the range. So this is in vertex form. We can identify the vertex right away. The vertex is going to be HK. Now remember, H is always the number that's inside the parentheses with the X. The K is the number that is not attached. So I always change the sign. So if it says -3, I know that I want a +3. The k value, even though it's first, is going to be the second half of my vertex. It's a +1. I keep the sign the same. If I want to identify then the axis of symmetry, remember it's always x equals a number, and that's always going to be the number that is the x value of my vertex. So x equals 3 is my axis of symmetry. Okay, so I know that if I was to make a table of values, I know that I want to put 3 in the middle of the table because that's going to be where the axis of symmetry is. And so then I'll have a mirror image on either side. So I'm going to pick 2 values to the left of 3 and 2 values to the right. I already know what my vertex is, so that's 3, 1. And then like I had mentioned in the other problem, you either have to just substitute in the top 2 numbers or the bottom 2 numbers. It doesn't matter. It's going to be a mirror image on either side. So I think I'm going to substitute in the bottom numbers this time. So when I substitute in 4, 4 minus 3 is 1. 1 squared is 1, so 1 minus 1, that's going to give me 0. And so that means because 1 to the right is 0, that means 1 to the left is 0 as well to have that mirror image. If I plug 5 in, 5 minus 3 is going to give me 2. 2 squared is 4, so really I have 1 minus 4, and so 1 minus 4 is going to give me -3, and so that's going to be the same as if I had plugged in +1. So now I have all my points. I'm going to plot my ordered pairs. Notice that my A value is technically negative, so my graph should be opening down. So if I don't have a graph opening down, I know I made a mistake. So if I have 1, -3, 2, 0, oh, sorry, I plotted that wrong. 1, -3, 2, 0, 3, 1, 4, 0, and 5, -3. Notice that, hey, there's my U. It's opening down like I said it should because my A value is negative. I want to draw in that axis of symmetry. It always goes through the vertex. So here's my x equals 3. And now that I have that, I can look at the picture to determine the domain and the range. So remember, the domain deals with the x's. Well, once again, because this is a quadratic, I can plug in negatives and square it. I can plug in 0 and square it. I can plug in positives and square it. So essentially, your domain is never going to change when we're talking about quadratics. It's always going to go from negative infinity to positive infinity. It's really the range that's going to change. So remember, the range is dealing with our y values. It looks like I am going down, so all of those negative values are going to get hit. But then the highest up it goes to the positive is whatever the y value of my vertex is. So I'm going to be going from negative infinity up to +1, and 1 is included, so I want to bracket. And there's my graph. All right, so let's talk about graphing quadratic functions when it's in what I call standard form. F of x equals ax squared plus bx plus c. So this time it's not in vertex form. We can't identify the vertex right away. So it says, consider the parabola defined by the quadratic f of x equals ax squared plus bx plus c. We're going to identify the vertex with this ordered pair. We have -b divided by 2a. That's how we get the value for x. Okay, notice that x equals -b over 2a because that's representing the axis of symmetry. And remember, your axis of symmetry is always on the vertex. So whatever your axis of symmetry is, that's always the x value of your vertex. And then essentially what the second part of this ordered pair is, it's just telling us, hey, now let's substitute that number into the function to get then the y value. All right, so let's look at an example. So we want to graph f of x equals -x squared plus 4x plus 1. So we want to identify the vertex, the axis of symmetry, and then we'll state the domain and range. So it is going to be important that we identify our A, our B, and our C. Okay, we've done this before when we had to do it with our quadratic formula. And so as long as everything's to the one side, it says f of x equals, then the A value is in front of the x squared, the B value is in front of the x, and the C value is just that constant. Okay, so we want to identify the vertex, but identifying the axis of symmetry is going to be what we're going to have to do first in this problem. So remember, axis of symmetry is always x equals negative b over 2a. And so that's why I needed to identify a, b, and c, because I need a and b in order to identify the axis of symmetry. So x is going to be negative, and then I'll have 4. I always substitute my values in with parentheses, and then I'm dividing by 2 times negative 1. So we really have a negative 4 on the top, and we have a negative 2 on the bottom. And so negative 4 divided by negative 2, x equals 2. So that's my axis of symmetry. So then as far as my vertex is concerned, that's the first number in my ordered pair. I just have to figure out what the y value is. And so to figure out what the y value is, I'm going to be creating a table of values where I know that I have to put 2 in the middle because that's where the axis of symmetry is cutting my parabola into a mirror image on either side. So a couple values to the left, couple values to the right. So this time I am going to have to plug in 2 in order to get that vertex. So I'm going to carefully, do order of operations. I've got a negative. So notice that because A is negative, I know that I should end up with a picture with my parabola opening down. But I'm going to do negative, and then in parentheses, I'm going to substitute 2 in, and I'm going to square it, plus 4 times 2 in parentheses plus 1. And so then that's going to give me a value to be 5. So that should be the highest point on my graph because that's the vertex, and my graph should be opening down. So now it's just a matter of you either pick the numbers 0 and 1 to plug in, or you pick 3 and 4. I'm going to pick 0 and 1 because when I plug in 0 to all those x's are just going to disappear. And so it's just going to leave you with that constant. So it's 0, 1, which means then it's also 4, 1. When I plug 1 in, I'm going to very carefully do that. So I've got the negative, and then in parentheses, I've got 1 squared plus 4 times 1 plus 1. And so that's going to give me a value of 4. And so that means also 3, 4 is another ordered pair. So I'm going to plot those points. So 0, 1, 1, 4, 2, 5, 3, 4, 4, 1. So notice that my parabola is opening down like I said it should because my A value is negative. I'm going to be drawing in that axis of symmetry where x equals 2. And then as far as stating domain and range, remember domain is never going to change. I can go from negative infinity to positive infinity. It's the range that is going to change based off of what my parabola looks like. So looks like because it's pointing down, it's going to hit all those negative values. So I can go from negative infinity up until the highest point, which is my vertex. And that looks like the y value is 5. 5 is included, so I want a bracket. And there's my problem. So I would suggest that you pause the video, try this checkpoint problem, identify vertex, axis of symmetry, and then state domain and range. All right, hopefully you noticed that my A value is positive because I didn't see a number out in front of the parentheses. My vertex was -4, -4. That's the lowest point on my graph. Axis of symmetry, x equals -4. Domain's always the same. Range goes from -4, which is included, up to positive infinity. All right, that's us recognizing characteristics of parabolas and graphing parabolas.